Alright, guys, welcome back. We shall continue from where we stopped the last time. And the last time we considered the posting list and the term document frequency. The summary of that is we need to list out all the terms in our corpus, remove duplicate from terms that are in the same document, list out the number of times the term occurs, and also have a linked list representation of the document ID in which the terms occur. So today we shall move on to document indexing, which is another way of conceptualizing an intelligent IR system, and that is that we can form an index by associating a document with one or more keys. For instance, in topic modeling, we can look at each document and label them. Okay, this document has to do with politics, or this has to do with sport, or this has to do with education. So, like here, you can identify a document by the name of the first author. So, uh, and that key will be used to identify the document later on. Don't let us forget that efficiency and fast access is our goal. So there are certain questions we need to ask ourselves if we are to go through that approach. One of which is, what data structures and algorithms should be used for creating and maintaining indices? Because we want it such that it will be efficient and it will be fast. So you can quickly think of dictionary, or what to call hash map in Java, as a very good data structure for such kind of retrieval and storage. So which attributes of documents should be utilized as keys? Like I said, should we consider the name of the first author as the key, or should we consider what the document is about, the topic? Maybe it's on news, or it's on uh, maybe it's on politics, or it's on sports, or what should we actually use as our keys? Because each document can have multiple attributes. For instance, when you take textbook material in a library system, so what should we use as our keys? Should we use the the field? Maybe it's a science textbook, or it's a history textbook, or it's an art textbook. And also we also have the conceptual challenges. So what concept usage? We specify keys that are useful in searching and retrieving information, and we select attributes as keys that can be reliable determined from document, and that's just what I've just mentioned. So let's look, for instance, in a library system where you can control the number of vocabulary. And when we say vocabulary, we're talking about the terms. So the vocabulary is list of terms whose meanings are specifically defined. For instance, if you're building uh, a, a search system for a medical field, or an hospital, or a healthcare, most of the terms in which they are going to be using are already defined, so there are no ambiguities. So in such a case, you have a list of terms that you can work with. And so once you have those lists of terms, users needs to be aware of those available vocabulary, so that when they need to make searches, they will pick from those terminologies, those terms. And this approach pursued in the context of digital libraries or catalogs. Then we need to do full text indexing. The index terms are automatically selected from document collection. So you have a collection of documents. Uh, you do indexing of the terms. So document need to be processed in order to extract the index terms. And that's important. We need to pass through the document and identify the index term. Selection heuristics for choosing appropriate terms and approach used by search engines. So we are revisiting our IR system architecture again, which still gives us both the views of which we have seen before. The IR system components. So what are the essential pieces that make up our intelligent information retrieval system? It must be able to research, it must provide a searching mechanism. It should be able to have ranking feature. It must have a user interface, and there must be query operations taking place. So the search helps to retrieve documents that contain a given query token from the inverted index. So our IR system should provide the searching features where it will pick whatever query the user gives it and go into the inverted index and retrieves the relevant document. Not just retrieving the relevant document, it must be able to sort the document too according to their importance using relevance metrics. And it must have a user interface to manage the user. That's like a box, maybe a box. It must have an output interface to return result. It must have a way of visualizing the result. And must have a way of receiving feedback, kind of maybe like a pop-up. Are you satisfied with the result? So it must also provide query operations. That is, it needs to transform the query to improve the retrieval, like we mentioned before. We might need to do some query expansion, some spelling corrections, stemming, as you also see later. You also go, it must also do, what's it called, potting. Uh, that is getting the dictionary meaning. Query transformation using relevance feedback. So in this, we'll be considering the retrieval models. A typical IR model should satisfy the following. Now, it should specify the details of the document representation, that is, how the corpus will be represented, the query representation, of course, and how do we compare the two. So, how do we do the matching between the user query and the document in the corpus? That's a function that does the scoring and should be able to determine the what is relevant. And notion of relevance could be binary or continuous. And what we mean is this. So you could, if you're having a binary model, a binary retrieval model or IR model, it means it's either 1 or 0. So there are no in between. So it means, okay, this document is relevant, this is not relevant. But if you have a continuous ranking system, it will not just say a document is not relevant or irrelevant. It will return them in the order of hierarchy. So it will be a continuous. Maybe one returns 10.0, another one may be 9.0% relevant, maybe one is 100% relevant, another one could be 90% relevant, another one could be 60% relevant, just like that. So there's a ranking to follow. So typical IR system, we've seen this before, just like a reminder. So in between our IR system and the corpus, we need to have a way of representing the document. We also need to have a way of representing the query, and we need to have a function to compare the two representations for matching. So there are classes of retrieval models. I mentioned quickly the Boolean models, which is based on the set theory. And the set theory is just like looking at the intersection of what you have in the query vector, and the document vector. So that's the Boolean retrieval models. So all that does is it just check whether the document is relevant or not. So it doesn't have a way of giving us the degree of relevance. So, and that makes it difficult to be able to rank the order of relevance of the document. The vector space models overcomes that problem, as we see later on, and the vector space model is mostly used in in practical purpose. What it does is this: it has a vector that represents the query plotted on a D dimension space, and it also has a vector for each of the document, and it does what? A comparison of how. Let me see if I can quickly do that for us to see. Let me go to my edit. Uh, okay. So what it does is uh, okay. So the vector space model. Let's take a simple two-dimensional space. So we have our x-axis and we have our y-axis. Okay. So what what this then do is this: it will okay. So it will plot the vector for the query. So let's say this is the query. Then it will also plot the vector for the query. I know this is taking a long. Okay, let me use same column. Then it will also plot the vector for the document. So let's say this is D1, document 1. Let's plot another document. This is the vector for document 2. So then it will now have a way of measuring how close is the query to each of the documents in our corpus. You could have a number of documents. This could extend more than just two-dimensional space. So obviously you can see here that the angle between the query and D2 is smaller compared between the angle between the query and D1. That means D2 matches more to the query, is closer to the query. Essentially, if you have a document that has exactly on the same vector direction, if there is a document that has the same vector direction with the query, then that matches 100%. In reality, that may not be always possible. That may not be possible. but you want to measure how well and how close it is. On the other hand, if you have a vector that goes completely on the opposite side of the query, so this vector is it doesn't match at all. So this document doesn't match at all. So that's the idea. So we'll look at that and latent semantic indexing, and then the probabilistic models too. We'll also look at that. So thank you for listening. Hope to see you in the next one. Thank you.